Good afternoon, students of class 11. Welcome everyone to once again to this online class. Okay. Now you know that we are discussing the chapter that is hydrogen. Last day I have told you about the oxidizing and reducing properties of water by some reaction. Okay. Now today I will discuss about the hydrolytic reaction or hydrolysis or hydrolytic reaction. So in hydrolytic reactions, the oxides, the carbides, these are takes part. Okay. Now I will in this class I will discuss about the hydrolytic reactions given by the different oxides. So first of all, example is that the metal oxide, suppose calcium oxide, CaO plus H2O. You know that the reaction that is calcium hydroxide. Okay. Next one, that is SO2. It is non-metal oxide. It will produce H2SO3. So it is an acid. P2O5 plus H2O, these equations are not balanced. H3PO4, it is also acid. So as the acidic oxide produces acid in its aqueous solution and basic oxide produces base, so it is the example of that kind of reaction. So the reaction is called hydrolytic reaction. It is one of the addition reaction. That means here only one product is there and the product is only the addition product. No part of this is subtracted. Next one is the carbide. Okay. So calcium carbide, aluminium carbide, these will react with water to form. Next one is the carbide, that is calcium carbide, CaC2 plus H2O forming calcium hydroxide plus C2H2. CaC2 plus H2O forming calcium hydroxide plus acetylene. Next one, Al4C3 aluminium carbide plus H2O. It will again form one hydrocarbon and one gases, that is here methane plus aluminium hydroxide. Here aluminium hydroxide plus methane CH4. So the importance of such kind of reaction is that it is used to prepare the hydrocarbons, and we know that hydrocarbons is used for the these are in gaseous form and it is used for the source of energy. Okay. So it will works as a source of energy. So C2H2, CH4, these will the byproduct of this reaction when carbide reacts with water. Next one, that is hydride. So hydride, that means when hydride reacts with water, it produces the base. You know this, that is sodium hydride plus water, that is base. That is NaH plus H2O forming NaOH plus hydrogen. In the same way, CaH2 plus H2O forming CaOH whole twice plus hydrogen. It is also the hydrolytic reaction. Okay. Next one is the nitride. Nitride, that is magnesium nitride. So magnesium nitride, magnesium phosphide, these will produce magnesium hydroxide and the respective one gas. One for nitrogen nitride, it is the ammonia; for phosphide, it is the phosphine. So follow the reaction, Mg3N2 plus H2O forming magnesium hydroxide plus NH3. Mg3P2 plus H2O forming magnesium hydroxide plus PH3. The balancing factor is that Mg3N2 plus 6H2O 3 2. It is 3, it is 2. It is 6, it is 3, it is 2. Okay. So, this is the nitride. So, when nitride goes towards the hydrolytic reaction, that is addition of water, it produces one base and one gas. Okay. Clear? Is it clear? Students, is it clear? Okay. So, in this section, that is in hydrolytic reaction, we have found the reactions of oxide with water, hydride with water, nitride with water, phosphide with water, and also the reactions with carbide, and carbide produces one acid. Now, the basic theory is that carbide, when reacts with water, it produces one hydrocarbon, and in this way, the importance of this reaction is that it produces one hydrocarbon, that is ethylene, acetylene, okay, methane, etc. Next one, that is formation of hydrates. You may also write this equation for your purpose. Next one is the formation of hydrates. Hydrate. So, when a crystal is formed, you have find that CuSO4 5H2O, ZnSO4 7H2O. So, these H2O molecules, these are joined with the molecule, that is with the crystal. These are joined with the crystal or with the metal atom by some bonding. What are these bonding? That means as a coordinate bond. Number 1, that is number 2, that is hydrogen bonding. Number 3, that is interstitial hydrogen. Interstitial compounds. Interstitial compounds. So, first one is the coordinate, next one is the hydrogen bonding, and third one is the interstitial. Now, coming to the first example, that is how coordinatically or in a compound like lithium chloride, when reacts with water, it produces Li H2O whole 6 within third bracket Cl. So, it is a coordinated complex, that is a complex entity, complex. Now, here the lone electron pair is donated to the lithium atom to form the bond. So, it is a coordinate covalent bond, okay, and the lone electron pair are coming from the H2O molecule. So, it is a complex where H2O is coordinatically bonded with the metal atom. Now, second one, that is hydrogen bonding. Hydrogen bonding, we know the example of copper sulfate. Now, if you follow the bonding pattern of copper sulfate, then it will be more clear that how these are bonded. Okay. So, there is the copper. Now, these are the H2O 4 water molecules are there. These are coordinatically bonded with the water with the copper, and sulfate is there, and in between these there is one H2O molecule. Now, you can see that these are all hydrogen bonded. So, the copper sulfate with 5 molecules of water of crystalline is the example of a compound where water molecule or hydrogen are formed, where the complex is formed by the hydrogen bonding of water molecule with the complex entity, because it is also a complex CuSO4 5H2O. Okay. So, it is the second one. And third one example is that is the interstitial compound, barium chloride 2H2O. barium chloride 2H2O. In barium chloride 2H2O, it is an example of interstitial. Now, what is the meaning of interstitial? That means we know that there is a definite pattern of crystal. That means when a crystal is formed, the metal atoms are packed in different manner, and with respect to that there are cubic close packing and hexagonal close packing. Okay. So, with respect to that, that is according to the crystal structure, there are some void spaces. Just for example, this is the void. So, this is void and these are the metal atoms. These are metal atom and this is the void. And in void, which atom will take place? Which molecule? That means which fitted in the size? Okay. In the void, the size of the molecule will be such that it can fit in the whole which is done by the, or which is created or which is produced by the metal atom. So, in this void, when water molecules are joined to make a crystal structure or a complex, then it is called the interstitial compound. And one example is that barium chloride 2H2O, here water molecule takes position in the void. Okay. So, this is the third type. So, first one was the coordinate bonded, second one is the hydrogen bonded, and third one is the interstitial hydrides. Next one, that is all about the elemental hydrogen. Next one is the what is deuterium. Now, deuterium is the isomers of hydrogen, 1H2 is the symbolic representation of that. Now, what is the importance of deuterium? That means here deuterium having application in different industrial field, mainly in the nuclear power plant, because it is used as a moderator in the nuclear power plant, and when D2O is there, it is called deuterated water, and it is used as a compound. This compound is used to restrict the speed of the neutron, that is it is works as a moderator in nuclear reactor. Okay. So, this is the one of the importance of using D2O. Now, how D2O is produced? For example, 29,000 liter of water is electrolyzed to produce 1 liter D2O. So, from this you can assume that what is the expenses to produce the D2O. Okay. So, in this way D2O is produced, and the physical characteristics of deuterium are greater than that of the, for example, the melting point, the boiling point, the specific heat, these are more than that of the water, because there is a relation is that when the atomic mass is increases, these property are increases accordingly. So, one example on this, that molecular mass for water it is 18, but for D2O it is 20. The density is, for water it is 1 maximum density, for deuterated water it is 1.1. Melting point and boiling point, for melting point it is 273 Kelvin, and for deuterium it is 276.8. So, this is due to the large molecular mass of deuterium, and deuterium is produced by the electrolysis of a very large amount of water to produce very little amount of deuterium. This is about the physical properties of deuterium. Next one is the chemical properties of deuterium. Okay. So, the chemical properties of deuterium will be done on the next class. Okay. So, today up to this only, that is up to the physical properties of deuterium. Next class it will be the reaction of deuterium, that is deuterated water, and also the some very basic reactions of deuterium. Okay. So, that is all for this class. Okay. So, we will come to again join in the next class. So, bye everyone. Thank you.